All right, good afternoon, everybody. I'll try to get through this without putting anybody to sleep. Um, what I'm going to do, I'll just cover the basics of bridge construction. Obviously, working for an engineer in charge, they're going to have you cover whatever they want you to cover when there's a deck pour going on. Prior to the deck pour, there's preparation to get ready for the deck pour, and the engineer in charge generally runs all that stuff. And what makes up the preparation, well, I'll get into it a little bit farther, and then usually a day or two before the deck pour, there'll be a dry run where the contractor, along with the inspector, the engineer in charge, will go through the machine, go across the deck, make sure the machine is set up correctly. Then we'll get into what gets covered on the actual placement day when you're placing the concrete, and then I'll touch briefly on curing and associated other things that happen after the placement. So the engineer in charge, they should prepare you guys, the inspectors, to be ready for when the deck placement happens. Get ready to get you familiar with the finish machine. There's a manual that comes with the finish machine that when there is a pre-placement meeting, the contractor has to provide that to the engineer in charge. Hopefully the engineer in charge will have you look through it. A lot of the finish machine manual just deals with setting up the machine, moving it, areas like that, but there is a little something on when it actually comes to placing concrete and how they should handle it. Also, get you ready to go out and do the dry run when that happens. Site manager, we all know every day you're doing a daily work report. Same thing when you're doing concrete placement. As I heard when I got in here earlier, the person talking about the asphalt, keep a paper copy of the DWR, pre-site manager, out in the field with you, because we don't bring computers out in the field with us unless we want them to get ruined. The daily structural concrete report is the MERC 5, and that'll catch all the information that you need to transpose all that information into site manager. You should be familiar with what material certs are required. Plenty of certifications have to be entered in through site manager. You have a lot more when you're placing concrete. Material specification, section 500 of the standard specifications cover Portland cement concrete in general. The bridge deck item is section 557. They'll talk about superstructure placement, sidewalks, approach slabs. So advanced preparation. A pre-placement meeting, in the specifications, they tell you to have the engineers should schedule that meeting at least 2 weeks prior to any placement of concrete on for the superstructure slab. Generally, a good rule of thumb that we tell the engineers in charge is about the time the contractor is setting the steel girders, that's about the time to have it. We want to have the meeting 2 weeks in advance. There's a lot of stuff that's covered. When you're having the meeting, you're going over stuff. All of a sudden you realize, oh, geez, we forgot about this. Oh, we forgot about that. And that takes time. You don't want to have the pre-placement meeting a day or two before the concrete placement because you could run into trouble. Also, once the girders are set, you're going to complete a haunch table. And the haunch table is used while you're doing the dry run out in the field. During the pre-placement meeting, the main office material came up with an agenda to cover various aspects of the placement. You have the general placement information, what date it's going to be, what time they're going to start, what the delivery schedule is, how they're going to place the concrete, is there going to be one pump, two pumps, a pump and a crane, where they're going to be located. A lot of general information is covered. Then we get into the materials information, and for the pre-placement meeting, besides the engineer in charge, they're going to have the regional materials engineer or somebody else from materials there, because then we say, okay, now the contractor has to tell us how much concrete they want per hour, what slump they want it at, what air contact they want it at. The materials people talk to material talk about, what admixtures you're adding for retarder, for air entrainment, and other things associated with the mix. Then the deck machine is discussed. What's the make and model of the machine? Where's the manual that goes with it? Is the bridge on a skew? Is the machine going to be set up on a skew? How fast are they going to be advancing the machine? You got the carriage that's on the machine, goes back and forth across the deck. It has a finishing drum on it. You know, we don't want to go too fast because we want to get a good finish on the deck. All that stuff is covered during the pre-placement meeting. Equipment, what equipment the contractor is going to have on site. Manpower, who's in charge for the contractor, who's in charge for DOT, how many people we're going to have out there. We don't want the contractor running around like crazy, not enough people on it, then all of a sudden concrete is setting up, it's not getting finished in time, and we end up with a bad finished product. Curing, how are they going to cure? What are they using for water? And this is mainly a good reason why the pre-placement meeting should be a couple weeks in advance. The water source. Is it municipal water? Well, that's generally not a problem, but if you're in a remote location and the contractor is going to be pumping water out of a river or a creek, well, that may need to be tested. And take a water sample, bring it into the lab in Albany. You might get the results in a week and a half. So that's why we want to set all this stuff up ahead of time, so when it comes time to actually place the concrete, everything's going to go smooth and there's going to be no surprises. Talk about the weather, hot, cold weather. How's the contractor going to handle if it gets too hot, if it gets too cold? What are they going to do if there's a supply problem from the plant? What's going to happen if a pump breaks down? Safety. How are we protecting the people? Are they wearing their PPE equipment? Are they protecting themselves? You know, what do they have out there for your people? And then miscellaneous stuff is, you know, stripping the forms. Are they looking to break early cylinders so they can get on the bridge sooner once they reach strength? Well, we need to know that in advance, because if that's what the contractor is planning on doing, the inspector is going to have to make a couple extra sets of cylinders come placement day. So this is a Haunch table out of a set of plans. They're basically the same on all bridge sets of plans that you get. Generally, the girder, the length of the girder is divided into 10th points. This one in particular is 20th points. So you take the length of the girder, divide it into 20 points. Surveyor is going to go out and take a shot on the girder, each girder, so then we can determine what the thickness of the concrete is over the girder when it comes time to do our dry run. And when we do the dry run, we're going to make sure it's set up correctly, make sure we're hitting the numbers that we should be hitting within quarter inch plus or minus, so that when it comes time to place the concrete, everything is going to be okay. Now, as far as the haunch is the difference between the top of the girder and the bottom of the concrete slab. So that's what we're calculating when the surveyor goes out there to shoot the haunches. Here's a blown up girder 1, blown up version of it. When you get the plans, you're going to have the required bottom of slab elevation. That's already filled in. They're going to give you the deflection based on the concrete that's loaded onto the girder. The girder is going to deflect a little bit. I made up some numbers here, so the surveyor is going to go out, survey the top of the girder, come up with these elevations. So then they take the difference between the bottom of the slab, top of the girder. So that's the depth of the haunch. Well, right here at the abutment, there's going to be no deflection because it's sitting right on the bearing. You start going out into the span, you're going to get a little bit more deflection, so your haunch is going to increase a little bit as you go out. So if we look at the diagram I showed you earlier, you got the haunch, you got the thickness of the deck, 9.5 inches, which is 0.79 feet. So for point L1 in the slide before, the haunch is 0.61 feet. So 0.61 feet for the depth of the haunch plus the 0.79 feet for the thickness of the deck gives you 1.4 feet. So when you go out there and for the dry run, you're going to go to every 10th, 20th point, whatever they have laid out, and you're going to measure from the top of the girder to the bottom of the finishing drum on the machine. So at point L1 on the first girder, you should measure 1.4 feet, which is basically 1 foot 5 inches, and that's the measurement you should have between the top of the girder and the bottom of the drum on the finishing machine. So when you get out there for the dry run, engineer in charge will have you out there if you're going to be the inspector up on the deck during the dry run. Verify that the finish machine is set up. Travel rails, generally the contractor uses 2-inch Schedule 40 pipe that the machine runs on. It's set up on the fascia on both sides. It's supported every 2 feet. All this stuff is in the specifications, so there's a place to find it. The engineer in charge should know where to find it. He should be pointing you to, well, review this so that when it comes out to do the dry run, you'll have an idea of what's going out there. Plus, they should be explaining it to you while you're out there so you learn. Verify the crown location. Well, if it's a straight bridge, crown of the road is going to be in the middle, so when they set up the machine, the crown should happen in the middle of the bridge. String line the carriage rails. On the truss that supports the finishing machine, and on the inside of each truss, there's a carriage rail. The carriage runs back and forth across the deck on that carriage rail. Put a string line on it to make sure that it's set up properly, it's nice and smooth, there's not going to be bumps going all the way across. And you verify the cross slope on the carriage rail. You have a smart level, set it on the rail, verify the cross slope. The finished machines, generally you'll see 2 of them. You'll see a bidwell and you'll see a Gamaco. They're generally the 2 that contractors use. There is an Allen, that's a new company, very similar to the bidwell. So the bidwell manual tells you that the center of the drum is where the grade is. So I'll get to a slide here shortly where the front of the drum's a little bit lower, the back of the drum's a little bit higher, so that at the center of the drum is where there should be no concrete. It should be off the concrete, and that's where finished grade is. Gamaco, they're a little bit different. The back of the drum is where grade is. You got to check the drum rotation and the carriage travel limit. With the drum rotation, we have 2 things. The drum's going one way, it's doing a compaction pass. If it's going the other way, it's doing a finishing pass. So you stand in front of the machine on the auger side of the machine, where the machine is going to be moving to you. And when you look at the drum, if it's rotating clockwise, and if the drum is moving to, when you're looking at it from left to right, it's compacting. It's rolling over the concrete, pushing the concrete down. When it comes back across, the drum's still rotating clockwise. However, it's striking off the concrete, and that's the finishing pass. The spec book tells you that the auger in front of the drum should be 1/4 to 1/2 inch above grade. If you look in the Gamaco or the bidwell manual, they're going to tell you that the auger should be 1/8 to 1/4 inch above grade. So, we're basically what's right there with the manual. So, as I said, every 10th point, every 20th point on every girder, you're going to be checking the haunches to make sure we got the proper depth. And randomly, you're going to go out to the middle of the same place pans that go between the girders, measure from there up to the bottom of the drum to make sure you got your 9.5 inch deck that we're looking for. You do that a lot less than what you'd be doing checking the haunches. Also the rebar cover. You're going to make sure that we have the proper cover on top of the rebar. Generally they're calling for 2.5 inches of cover over the top mat of rebar, so you're going to be checking top of the rebar to the bottom of the drum randomly throughout the deck to make sure that we got the proper coverage over the rebar. We're going to check the end bulkheads, make sure that the machine starts off the deck, they start placing the concrete on the deck, they pull the machine on the deck, so they have to get through that first bulkhead. If that bulkhead's higher than the machine, you're never going to get the machine on the deck. That's another thing that you look for at the dry run. And at the end of the bridge, they need to keep going off the deck with the machine, not once the front of the deck the machine gets to the end of the deck that you're done. They have to keep on running the rollers past that, and then there's also a drag pan behind the rollers that also smooth out the concrete, so they have to go completely off the deck. Overhang braces, that's what's going to support the fascia forms on the outside of the bridge on each side. It's usually angled down to the girder, holds it in place. The one thing to check is if it's stage construction and you're only doing half of the road at a time, make sure that overhang fascia form is not formed up and wedged up against the existing bridge that's still there, because that's going to prevent the bridge from settling and the camber coming out of the beam. Verify that the rebar is supported through the bulkheads. If the rebars go through the bulkheads, workers are going to be stepping there. The finishers are going to be walking back and forth. They're going to be hitting the bars. It's going to cause the bars to vibrate. It's going to vibrate into concrete, so then you're going to have an area that cracks. So you got to make sure that it's supported. Generally, they'll put a couple of 4x4s, a couple of 2x4s underneath it, put a piece of plywood on top of it. So once everything is done with the dry run and the machine is set and everything's set to go, well, the last thing you should do is measure the legs on the finish machine. You got 4 legs. You go up from the top of the bogey wheel up to the bottom of the hydraulics where they crank it off and take a measurement. Write that right on the machine. Do all 4 corners. That way, the next morning when you come in, you remeasure it again, and you'll know if anything happened overnight. If some kids come in and crank down one of the legs, did something in the machine got a hydraulic leak or something that's causing the legs to, move during the night, or, some odd thing happens. So that's why you want to measure it once you're done with the dry run, and then measure again the next morning prior to placing any concrete. And Exhibit 557F of the Construction Inspection Manual talks about what to do during the dry run. So placement day, prior to starting, you need your testing equipment. Everybody that tests concrete, whether it's DOT employee or consultant, has to go through the concrete testing class. We have the in-house PCC training that the construction office materials group should be given to you. Any consultant should be ACI certified. As I said before, the MERC 5D is the paper form of the DWR. You get that out in the field, it's going to get wet, it's going to get concrete on it. So you can fill that out, then transpose all the numbers into site manager once you get back to the field office. You need a concrete temperature, so you need a thermometer. You're going to do a slump test. You're going to need an air pot with the backup. Because there's been times that you're out there, you got a 5-hour, 6-hour, 7-hour, 8-hour deck pour, and things are going good, and all of a sudden halfway through you're testing concrete, and all of a sudden you blow a seal on the air pot. Well, it's always good to have a backup. Or, something happened to the air pot that you have on site, and all of a sudden you're getting bad readings, and we're start rejecting trucks, and nothing makes the contractor matter, or even the concrete supplier matter, and anger at us, and we're rejecting trucks, and then they accuse us of testing wrong. Well, break out another air pot, check it again. Have them bring out an air pot. Compare to, each one to each other, make sure the numbers are close. And also with concrete, you need to be IS trained by a materials group, so they're going to catch you sometimes to, make sure that you're doing the tests right, you're getting the same numbers you should be. So a lot of good time to catch people during the deck pour. You got to have your cylinders so you can make cylinders. You got to know how many cylinders you got to make. If they want an early cure, an early break, because they want to open the bridge early, you're going to extra set of cylinders. You need to know all this ahead of time, have it out there before they place any concrete. Contractors should supply you an area to test your concrete. They should give you a piece of plywood to do your slump test on, make the cylinders on. They should supply the wheelbarrow to get your concrete, 5-gallon pail for water, a shovel to clean things up. Here we go. We're going to remeasure the legs, make sure nothing changed. Everything's good? All right, we're good to go. So, this falls more on the engineer in charge to make sure it's right, but as inspectors, you're extra eyes out there, so you should be checking this stuff out. So if you see something that's not right, bring it up to the engineer in charge and say, hey, how come they don't have 2 pump trucks there? What's going on? Ask the question. Don't be afraid to ask the EIT the question. He could be thinking about 5 other things that's going on in the job and saw the concrete pump right there at the bridge deck and, didn't look around to see if there was a backup around somewhere. So as an inspector, you're there to assist the engineer in charge. So make sure that the pump is there in the backup, or if the backup's a crane in a bucket, make sure that's nearby. Contractor has to, getting out of control here. Contractor has to have 2 vibrators minimum. Says that right in 557-305. Contractor shall have 2 vibrators on site minimum. It also says that they need 1 vibrator for every 40 cubic yards per hour they plan on placing. So if the contractor's planning on placing concrete at a rate of 30 yards an hour, they're going to say, well, I only need 1 vibrator because I'm not exceeding the 40. It's like, no, you don't. You need 2 because it's 2 minimum, and they need a backup. Poly, in case it rains in the forecast, what's the contractor going to do if it rains? Well, they got to have poly on the site in case a shower comes through, they can cover it up. Everything here that should be on site is nothing new to the contractor. It's nothing new to the engineer in charge. It shouldn't be anything new to you if you were at the pre-placement meeting, because all this stuff is discussed at the pre-placement meeting. Make sure they're going to use sprinklers. Make sure if they're pumping out of the creek, well, make sure the pump works. Do they have, if they're using municipal water, they have a wrench to turn the fire hydrant on. I mean, they have to make sure everything functions beforehand. Concrete supplier, well, it's nice if the concrete supplier representative will be on site. They don't always show up. If we start getting bad concrete, we start rejecting concrete loads, don't worry, they'll show up. They'll be pointing the finger at us, telling us we're doing everything wrong. Well, hey, no, you're giving us bad concrete because our inspectors at the plant is not releasing the concrete at the plant unless it passes a test there, so something's happening, or your drivers are doing something to us. So they'll show up if they need to be there. Every concrete truck should have a DOT sticker, and it's usually inside the cab. This last thing about checking the evaporation rate, if it's a dry, windy day, concrete's going to dry quicker than normal. The surface is going to flash dry, could cause problems with finishing it. So we got to make sure that the evaporation rate does not exceed 0.25 pounds per square foot per hour. And generally, the contractor, even though it says the contractor should test this and confirm this, they'll usually give us the tester, which is like anything else this day, a little digital thing. They hold it up, push the buttons, and it tells you the evaporation rate. It'll give you the wind speed and the humidity that you can figure it out. Someone old like me, or if anybody's been around, there used to be a thing called a sling cyclometer that used to swing over your head for about 2 minutes, and then you take some readings off of that and compare it to the temperature, and that chart, you go into the chart and you figure out what the evaporation rate is. So with the spec books online nowadays, there's no reason that this figure 57-1 shouldn't already be printed out into a clipboard with your other paperwork. So for a deck pour, we're going to have people at the truck. We're going to have people on the deck. So if you're an inspector down at the truck where they're dumping into the pump truck, well, you should have 1 or 2 people. If it's a long day, a lot of testing for one person to do. So it's good to have a couple people there. Also, the inspector's duties. This was something else that the materials group, main office materials group, came up with and provided it to the regions to pass out to their construction folks so that they know what's going on out there. So when you're setting up your testing station, they give you a piece of plywood. Usually it's a form. It's already got the form oil on it, so it's not going to absorb any water. Got to make sure it's level, so when you pull your slump test up, the slump cone doesn't fall over, and you got to start all over again. Got to make sure that the contractor, has somebody there when they're backing the trucks in. We just don't want the concrete trucks backing in, pulling out, pulling in, backing out on their own. Once again, that is discussed at the pre-placement meeting. So when the material arrives on site, you get a copy of the batch ticket. You got to make sure that the mix that is called for on the deck is on there. Make sure that the D number is on there. You probably heard it earlier today for other materials, asphalt, maybe the gentleman talked about it. But you have to sign every ticket. Back in the day, we used to be able to initial the tickets. That's no longer good because when the office comes out and do a MERC review, they require that every ticket is signed. So you have to sign your full name to it. So once again, you're going to check the trucks as they come in to make sure they got the inspection sticker. They can only have so many revolutions on the truck once they're mixed in, so you check the counter, see how many revolutions they got, see how many more revolutions they can put on it. Another thing that is discussed at the pre-placement meeting, and it's good for the inspector to be there, but if not, the engineer in charge to pass on to you, the contractor will tell us what slump they want that truck to be at when they pull into the site. If the limit for Class HP concrete is 3 to 5, contractor may say, I want it on site at 4.5. Well, that's fine, you want it on site at 4.5, but be aware, you're within a half inch of the limit. If it shows up at 4.5, you cannot add any water to that truck all the time that's on the site. You sure you want it at 4.5? They may say, yes, it's 4.5. It's like, fine, you're paying for the concrete, you're placing it, you're dealing with it. So it's good to know how much water they can add. The inspector will put on the ticket how much water was added to the plant, if any, so you know how many more gallons you can add at site. And once you add the water, you got to put a certain number of revolutions on it. Got to make sure the chutes on the truck are clean. They usually, as long as they don't got old concrete all hardened up on there, because we don't need that to get into the pump truck, to get stuck in the hose, to spit out onto our deck, be buried in the deck somewhere, and we have a spot for failure. And then if there's any issues with the materials or the vehicles, and it's the same truck, the guy's coming in right at the upper limit, well, he's not out of spec yet, but he's at the upper limit. You may want to mention to the EIC, this guy's been coming in at the upper limit all the time. All the other guys are coming in right on. Is this truck leaking water? Is the truck driver giving it a little shot of water about 2 miles from the site? Just let the EIC know so that they're aware of it. EICs do not like surprises. They want to be made aware of things that might cause a problem down the road. So now, up on the deck, you're in front of the machine, or you're behind the machine. In front of the machine, where the concrete's going, the deck should be clean. There shouldn't be pieces of tie wire in there. There shouldn't be empty coffee cups. There shouldn't be chunks of concrete. There shouldn't be chunks of styrofoam that they use to, put into the bulkhead. There shouldn't be pieces of plywood, nails, anything. So make sure that it's clean. And if it's a precast, if you're pouring the deck on top of precast beams, well, that needs to be pre-wet. Make sure that there's no standing water on the deck. So when they start up with the concrete, they start pumping it onto the deck, we got to make sure that the concrete is vibrated properly. The vibrator people should be the last people stepping into the concrete. I have a picture coming up where it shows a deck pouring sequence, and I'll get more into what the vibrator person should be doing out there. Make sure the finish machine rollers maintain a rigid concrete on the cut and pass. So when they're doing the finishing pass, it's also the cut and pass. At the front of the drum, it should be about golf ball size, and then it should taper down to nothing. If it's Bidwell, it should be nothing in the middle of the drum. If it's a Gamaco, there should be nothing at the back of the drum. Give or take a little bit on the drum. As long as it's finishing nicely, we don't need to be exact. It's a bridge we're building, not a watch. They put a pan on the back of the machine. It floats behind the finishing drums, and it just, once again, it's like a trowel finish on top of the deck. Contractors are going to say, do I have to put the pan on there? Well, that's the engineer in charge to make that decision. We call for the pan. If they're asking, it never works good, I always had trouble with it, well, they're not putting it on correctly. Usually, once the contractor puts it on and they got it set up correctly, the pan offers an additional finish to the deck, and usually everything works out good. May need a little bit of weight on there just to make sure that it finishes properly. So, if the contractor's asking, the inspector, well, hey, do I need the pan? Well, have the engineer in charge answer that question, because he's the one making the big money on the job for DOT, so let him take the responsibility if he tells them, no, you don't need the pan, even though it's required. So on the back of the pour, once the concrete finisher goes over the concrete, they're going to broom finish the concrete, and then they're going to start setting the curing, and the curing is they're going to start off with wet burlap. Well, the wet burlap needs to be soaked overnight. Once you're done with the dry run, ask the contractor. You got Usually it's a cattle trough, and they just got rolls and rolls of burlap in there. It's like, all right, where's your wet burlap going to be? Well, hopefully it's behind the deck pour, so when they bring it on the deck, they're following the machine. They don't have to carry it past the machine to put it out. So the contractor should show you where the burlap is. Here it is. It's, we're going to put it in this afternoon. Well, before you leave that day before, make sure that they got it covered with water. The broom finish, turf finish, it should be, usually they use a new piece of turf drag. They'll put it on, some contractors put it on a full flow. Other contractors, a little more creative, they'll take a 6 or 8 inch piece of PVC round pipe, wrap it around that. That way it's more cylinder shape, so that when the guy's up on the work bridge pulling it, if he's out like this and it's 10 feet away from him, or if he's 3 feet away from him, it still has that nice curved shape, so he's still getting a nice broom finish on it. They should have a straight edge. Contractors are required to have a straight edge. They should put the straight edge at the beginning when they first start off on the bulkhead, and set it down gently on the deck, and there should be no valleys or anything in there or any humps that is going to give a bump as you're driving over that road. The inspector is also going to make sure that the finish is happening properly. It looks nice and smooth. Everything looks good. There is, in the specification, it states that from the time the concrete hits the deck in front of the machine to the time that it is covered with burlap behind the machine should take no longer than 30 minutes. The reason for that is if it's finished and it's not covered up with the wet burlap, that it's going to start drying out, and that's where we get into scaling problems. So you make a little mark on the rail right in front of the wheel, mark what time it is. Well, when the burlap gets there, well, is it less than a half an hour? Okay, we're good. It's under a half hour. Generally, when you first start out, there's a lot going on. There's a lot of hand finishing going on. So when you first start out, you may not hit that 30 minutes, but once everything's running smoothly, there should be no problem hitting that 30 minutes. And the wet burlap, they'll bring that out on a work bridge. People set it down, overlap it 1 foot from the piece behind it. Once that's there, the contractor just can't forget about it. They need to go back, and if it's starting to dry out at the very beginning, well, they need to get out there with a hose and put a fine mist of water into the air just to keep the burlap wet. And that should start 5-10 minutes after the burlap is in place. So, first truck line shows up on site. Going to test the first truck, make sure it's in spec, make cylinders. Now we're going to check the conveyance, how they're conveying it, make sure we're not losing more air or the slump is getting too stiff. Depending on the pumping company, I'm from Albany. The Precision Pumping is who we use. Their oldest truck they have is probably 3 years old. They're constantly buying new trucks. We never have a problem with them because all their equipment is new. They take care of the equipment. But if you get a ratty-looking truck showing up and it looks like the guy doesn't take care of it, well, you may want to check the concrete from when it goes into the truck to when it comes out of the end of the pump hose. We accept the concrete at the point of discharge of the truck. So that's why we have to check the pump truck. If the pump truck is taking too much air or too much slump out of the concrete, we can reject the pump truck. So the air, it can vary 1.5%. The slump, if it's 4 inches or less, when it goes into the pump truck, it should not lose more than 1 inch. If it's greater than 4 inches, it shouldn't lose more than 1.5 inches. There's a lot of times that we don't test this, like I said, because all the trucks are newer, but if you got an old ratty truck there, you want to take this test at the very beginning because you got the concrete truck set up, you got the pump trucks there, you're right there at the beginning of the deck. When you grab a 5-gallon pail of concrete to take back to do an air test, you don't want to lug that 3/4 of the way across the deck. You want it nice and close and easy to get through. The pump discharge. The specification states that the concrete shall be discharged horizontally of minimum distance of 3 feet. So that's what that's saying is that at the end of the hose, there should be an elbow and it should go out 3 feet. Well, that's not very practical because people are going to be tripping over that. It's a hazard. It's kind of a pain to handle it for the pump hose guy. So in order to get around with that, like I said, if that's not possible, use a double 90 at the end, or what a lot of these pumping companies use is a taper hose. 5 inches up there at the end of the boom where the hose starts. It's 4 inches at the bottom where it discharges. What that does, it keeps concrete in the line so it's not free-falling when they're not pumping and causing segregation, which gives us a bad deck. Okay, so here we have this concrete placement. Here's our truck boom. Right there, there's a reducer, steel reducer, goes from 5 to 4. And then this hose right here is 4 inches. Like I said, a lot of the trucks now just have the hose that goes from 5 to 4 inches at the bottom. Here's our hose guy. Right next to him is the vibrator guy. He's walking along with that guy as the concrete's going into the deck. He's hitting it first, vibrating, just following that guy around. And materials talk, there's what is called the zone of influence. You stick the vibrator into the concrete straight up and down. We don't lay it down and drag it. Straight up and down. You'll see how far it vibrates out. That's considered the cone of influence. So if it's a foot, foot and a half, it should be sticking the concrete with the vibrator every foot, foot and a half. So this guy is just going to follow that guy around all day long. Here's a pump operator. He's right on top of things so he can, see what's happening, move the hose so he's not jerking this guy around, yanking him this way, that way. And when he tells him to stop pumping, he's going to stop pumping. Well, here's the other vibrator guy. He's back here just in front of the machine. That's a good place for him to be, and he's facing the machine. That's good also because a lot of times you'll see the vibrator guy, he'll be walking around, walking forward, vibrating, taking out footprints, but he's putting his own footprints in the concrete. Well, that doesn't solve anything. So he should be walking backwards or he should be walking sideways so that the vibrator is the last thing to hit the concrete before the machine hits that. So as far as rakers, there's 1 raker, there's 2 rakers, there's 3 rakers. Over here is the finishing machine. So if the auger in front is going to build up some concrete, the rakers are going to be pulling it back. So rakers are walking back and forth, pulling concrete back. Hence why we need a vibrator guy to take out the raker's footprints. A lot of rakers, they don't like to stand around. They think, oh, the boss is watching me and I'm not doing anything. They want to keep raking. No, let the machine do the work. There's nothing here. We're all working over here. This guy's vibrating over here. Concrete's over here. So, well, if this guy has done his job, we'll get a couple-minute break here in the middle. You got a finisher over here. There's probably another 1 or 2 finishers behind them. Over here you got 2 finishers. There's another finisher. They're finishing where the machine can't reach. The machine can only get so close to the fascia. Here we have guide rail going in, so the machine can't go past the end of where the bolts are going for the guide rail post. So the finishing guys, they're finishing back here by hand. And they also have a small piece of turf drag where they're dragging the turf, doing the same turf finish on the deck that is getting done out in the middle. The work bridges are back here behind the machine. Got the operator up here. This is a single drum machine, so as the machine is moving this way, you're standing here, the drum is rotating clockwise. It's going across the deck from left to right, beating the concrete into itself, so it's compacting that. When it's coming back, it's still going clockwise, but now it's going right to left. It's striking off the concrete, finishing. Well, it should be finishing towards the operator. He should be seeing the front of the drum so he can keep an eye on how much material is in front of the drum and make sure that they have proper golf ball size roll down to nothing in front of the drum. Hose reducer. Here's a hose. It goes from 5 to 4. Looks like any other regular black hose that's covered with concrete. However, in this picture, there's a red stripe on it, and that red stripe says reducing hose. The other thing the pump company they have may just be a short piece of steel pipe where they're reducing at the end of the boom. Loading on a skew. If the bridge is on a skew, the contractor should be loading the concrete on a skew. The reason for that is that so each girder is getting loaded at the same time and the camber is coming out of all the girders in uniform. So the machine needs to be set up on a skew to follow the skew of the bridge deck. Here's the stage construction, or it's not stage construction, it's a smaller bridge. We got a sidewalk over here where this mason's standing. We're going to have a barrier over there, so, you know, they may have 2 rakers. They don't need the 3 rakers. They got the 1 vibrator guy, maybe enough to handle it because they're not putting a lot of concrete in front of the machine. They're not getting that far ahead of them. Even though the specs calls for 2 vibrators minimum, you get into stage construction, if you're only doing 10, 12 feet wide, the 2 vibrator guys are going to be tripping over each other. So it doesn't make sense. Once again, the engineer in charge will make that decision, but generally we should have 2 vibrator guys out there at all times. So here's a bid well. We got the concrete in front of the auger. Their manual says 1/8 to 1/4 inch above grade the auger is. Front of the drum, 1/8 of an inch below grade. Back of the drum, 1/8 of an inch above grade. That puts the finishing point right at the middle of the drum. Here they actually got 2 pans. Usually it's only 1 pan, but for, you know, they're probably trying to sell the contractor the elite package, so it tells them that you need 2 pans, and you also need the turf attachment back here. The specifications say that the turf should be hand turfed by a person on a work bridge. So they're going to try to, you know, sell the contractor the best package they got. Pour direction, we're moving left to right. So you got to make sure that there's not more material in front of the auger that's going to cause the auger to lift up, because if the auger lifts up because it's trying to push too much material, it's going to cause the drum to not finish correctly, and it's going to screw up the whole works. So we got to verify that it's not being overloaded. Verify that the golf ball size roll starts there, goes down to nothing. Verify that the turf drag is applied 5 minutes after finishing. 30 minutes from when concrete's placed in front of the auger, but when the contractor puts the turf drag on the concrete, they should have it covered with burlap within 5 minutes. And the manual tells you, once again, only fill up the auger half full. There's that little golf ball size roll I've been talking about. So it's a double drum machine because I can't talk. A double drum machine, it has 2 drums on it. They're rotating in different directions. The one drum is just standing in front of it. It's rotating clockwise while the other one is rotating counterclockwise. The benefit of a double drum machine is this allows the contractor to advance on the deck after each pass. They go to one side, they can move forward 6 inches, go to the other side, move forward 6 inches, because they cannot advance the machine until the finishing pass. So on a single drum machine, they have to go over the deck with the compaction pass, come back with the finishing pass, then they can advance 6 to 8 inches. So they can move a little faster with a double drum machine. The only trouble with a double drum machine is the golf ball size roll is between the 2 drums. Pretty tough to see what it is, but if they have too much concrete in there, it will dribble out behind the back of the drum, so you know that, you know, the auger is too high. Mainly that's the cause. If they have concrete coming out from the back of the drum, it's because the auger is too high and they're not pushing enough concrete away from the machine. So single drum machine, Damaco, front of the drum, auger. Front of the drum is 1/8 of an inch below. Back of the drum is at desired grade, so that ball of material should go all the way back to nothing back there. Here the single drum, they talk about the consolidation path. It rolls over the concrete to spread and compress it. Finishing pass, it stripes it off. And there's the drag pan behind it. Here's a single drum machine. Yeah, that's about a golf ball size roll. Looks pretty good. It goes back maybe 3/4, a little bit more than 3/4 of the way back to the drum. Close enough to the back of the drum. We're getting a good finish. Finish doesn't look too bad there. We got the drag pan on there. It's looking pretty good there. Here, this has been turf drag, so it's, we smooth it off and then we rough it back up a little bit. So everything here is looking pretty close, pretty tight. Golf ball size roll, well, that's probably not really golf ball size, but they got a little extra there. The material could be a little wetter, so you can get a little more material in there. But it does dissipate before it gets to the back of the drum. It's still finishing good. The drag pan, still doing a good job there. So everything's looking good there. Turf drag. Here's our guy up on the work bridge. He's just going to walk back and forth. He's going to pull the turf drag across. Looking pretty good. You can tell that the turf drag they're using is new because it's leaving nice grooves here. Here's the finisher over here where the machine can't reach. When we have the pre-placement agenda, it's going to ask the contractor how far out from the edge of the bridge are you going to trowel finish. Usually we do a mag width, which is 18 inches. So 18 inches out from there is just going to be smooth, so the turf does not go all the way to the edge. Mainly that allows the flow of the water to go off the bridge when it comes drainage time. So this guy back here is doing a little hand finishing, and then if he has to make any adjustments where the machine can't reach, he'll turf drag it by hand first, and then he'll finish it with his float. Here's our 2-inch rail that the machine runs on. Burlap is being kept right up with the finishing guy, so everything's looking good here. Curing. Here we go again. Wet burlap shall not exceed 5 minutes from completion of the texturing and 30 minutes from the time of concrete placement. So I think I mentioned that 3 times today. It's in the spec book. It's in the sim. It's discussed at the pre-placement meeting, so there shouldn't be any surprises when you tell the contractor, hey, let's pick up operations a little bit. You're running behind. You're not getting the burlap on there quick enough. Burlap should be kept continuously wet 10 minutes from the time of placement. Once again, don't just put the burlap and keep moving forward and don't look behind them, because contractor move forward, move forward, move forward. Well, what's happening behind us? It's a windy day. Burlap's starting to dry out. Well, get somebody back there with a hose to put a fine spray to wet the burlap again until the placement is done, and then they put out the soaker hoses or the sprinklers, and then it's continuous wet. The curing period begins once the placement is complete. 14-day wet cure on the deck. Contractor pours on, well, I start 8 o'clock in the morning, 14 days from today. I want to start pulling off the burlap and stop the wet cure. Well, that's when you started the placement. It's when you end the placement is when the curing time actually starts. So, yeah, at the end of the day or tomorrow, 2 weeks plus 1 day, you can turn off the water and start removing the wet cure. A curing day is 24 hours above 45 degrees. The engineer in charge should know this, keeping track of the temperatures. Contractor can aggregate curing hours. So if it drops down to 40 degrees overnight for 8 hours, well, they didn't get 1 day. They got 16 hours, so they got 2/3 of a day. So once they get 14 days, 356 hours or somewhere in that ballpark, is when the cure is complete. So they need to wet cure it 14 days. Or they can continuously wet it for 7 days and then put curing covers over it. Something new that we just started using within the last couple years is HP internal cure concrete. What that is that the fine aggregate in the concrete, 30% of that is made up lightweight. That means it has air voids in it. So while the aggregate is wet, it's going to retain moisture and it's going to help with the cure, hence why it's called internal cure. So the waiting period is only 7 days. That's why we have materials people at the pre-placement meeting, because they know all this stuff. That's their job. They know inside and out. We refer to them when they get to talking the material stuff. You and the material guy from the plant can talk about everything you need to talk about, including the aggregate and where they're getting it and the hardness and all that stuff that us people out in construction we care about, but it's not our main focus. That's why we have a materials group to support us. Approach slabs, sidewalks, safety walks, wet cure should be 7 days. That works out good for the contractor because they're going to pour the deck, they're going to form up the approach slabs, they're probably going to place the concrete in the approach slabs a couple of days later, a week later. So now the deck and the approach slab is coming out of wet cure at the same time. Plus the wet cure is less on the approach slabs because it's sitting on the ground. It's not supported by girders and needs the additional cure time. And beware of the bridge grade. Water flows downhill. If you're on a long bridge and they have different pour sequences, the first day you're going to start at the beginning abutment. You're going to pour out so many feet. You're going to skip to the center pier. You're going to pour so many feet. You're going to skip to the end abutment, pour so many feet. Now you got 2 areas in between that you need to pour 3 days later. What they poured the first day is now having wet cure applied to it by sprinkler or soaker hoses. They're going to start the concrete placement for the 2 middle sections, depending the grade of the bridge. Once you start pouring, the ideal thing is always place concrete uphill. Machine's working uphill, getting a better finish that way. The middle section is being wet cured. Well, they should turn the water off the middle of at the beginning of the day, or at least not any later than halfway through the pour, because it's going to take the water time to get to the edge, run down the fascia. So you don't want to be getting up near the section that you poured 2 days before, 3 days before, and all of a sudden you got all this water running onto the deck where you're putting fresh concrete. That's bad news. All of a sudden your concrete's a little too wet. So that's one thing that your engineer should be in charge of. But like I said, engineer has a lot of things going on the job. May not think of that. Just ask the contractor if you're doing a different sequence. Hey, did you turn off the water on the upper section that we poured the other day? Otherwise, they're going to be up there with buckets and shovels and shop vacs and air blowers and anything else and get their hands on to blow the water out before we place the concrete there. Here's a burlap being applied. Tight operation. We got the carriage. We got the burlap right behind it. Everything's getting covered up quickly. Helps that we're in the shade here, so the sun's not beating on the deck, so that helps keeping the concrete from drying out. Here's everything keeping close. We got the raker. We're only 3 feet in front of the machine. The contractor's got this timed perfectly so they don't get too far ahead of themselves with the concrete in front of the machine. That's the worst thing you can do is get too much concrete. Well, they got 90 minutes from when the concrete is batched to get it out of the truck. What do they want to do with it? Put it in the deck. If they're 20, 30 feet in front of this machine, that's bad news because this concrete out here is going to start setting up. Finish the machine. We got the drag pan right behind it. There's a turf guy right behind that. Burlap's right behind that. Everything's moving along smoothly here. Finishers are over here just working hard, keeping everything moving. Here, can't get much closer than this. You don't even have another width of the drag, or the turf drag here without be hitting the pan, so this is very close. And they're putting the burlap down right behind that work brake, so they're cranking right out on this front. Everything's timed perfectly, everything's working smoothly. Get all this stuff worked out at the pre-placement meeting so that when it comes time to do the concrete, everything is moving along like a fine old machine. There's no delays. So as far as deck placements, there's all kinds of reference materials besides the specifications. In the Construction Inspection Manual, 557D talks about the advanced preparation, the dry run. Pre-placement meeting, 557E, talks about what should be discussed at the pre-placement meeting. Also, we have the agenda that main office material came up with. The dry run, 557F, talks about what should be happening at the dry run, what you need to check out there. Day of the pour tells what the inspector should be doing, and we have the additional duties from main office materials that gave us an idea of what the inspectors at the truck should be doing, what the inspector behind the machine should be doing, what the inspector in front of the truck should be doing. Special circumstances, 557H, talks about, well, if the plant breaks down, all of a sudden the shower comes in, just things that no matter how much you discuss at the pre-placement meeting, you cover all the basic stuff that we expect to see happen out there, but a lot of stuff happens out there that you don't expect to happen. Sometimes the finishing machine will come off the carriage and drop into the deck. Well, now the worker's got to walk on the deck, can't do much about it. They're going to walk through all the concrete to lift the finishing machine back up. A work bridge is going to break and it's going to fall into the deck. Well, we didn't talk about that at the pre-placement meeting because we didn't think it was going to happen, but it happens. You know, get the crane, get the work bridge out of there, fix it, get a new one in, whatever it takes. Meanwhile, now they got to go back and finish that area by hand. It's not ideal, but there's not much else we can do there. You have all this reference in the sim manual. You have reference in the spec book. You have your engineer in charge to ask questions of. Don't be afraid to ask your engineer in charge questions. See if they know what they're doing. Ask them, keep them on their toes. Ask them questions, you know, just out of left field. What about this? What about that? See if they have the answer for it or look it up. Look it up first before you go run the engineering question. I know we've gotten to the point where inspectors like to ask the engineer, you know, about things should be done instead of looking up in the spec book. As a construction supervisor, I have engineers in charge ask me, well, what should we do here? Well, what does it say in the item? Look that stuff up so then you have an idea that you look for the answer first and it still ain't clear for you. Say, well, I looked this up, tell you I see, but I still need a little further guidance on this. What do you think? And they should be more than willing to help you.